we're going to play a little bit more with this. To shorten the notation, I'm going to define PW as the probability that the word W is present given the relevant class. QW is the probability that the word is present given the non-relevant class. So you pick a random relevant document, what's the probability that BIR.8 is present? That's P BIR.8. Next assumption we're going to make. We're going to assume that the empty document, so the empty vector, the vector of all zeros, has the same probability under the relevant class and the non-relevant class. So this 0 with a vector sign, it just means a document where the first component is 0 and the second component is 0 and a third component is 0. What does a document look like? It's empty. It doesn't have any words in it. So what I'm saying is an empty document is equally likely under the relevant class and the non-relevant class. Why am I doing this? I'm now going to take the formula, so that's our ranking formula from the previous slide, and play around with this based on that assumption. But first, I'm going to take the products and reorganize them slightly. Okay. So I have two products that I'm dividing here. This is going to be my numerator, this is going to be my denominator. In both cases, the product goes over all the words in the vocabulary, every word, both the words that occur in the document and words that don't occur in the document. For the words that do occur in the document, I'm using PW, right? Because PW is the probability that the word occurs in a document, assuming that it's relevant, and those words do occur in the document. For words that don't occur in the document, I have to use 1 minus PW, because that's the correct probability of the event. The probability that the word does not occur, assuming that we're in the relevant class. So that is the numerator, and similarly, that is the denominator. So I'm using PWs and QWs for all the words that occur in the document, and 1 minus PWs, 1 minus QWs for all the words that don't occur. Now I'm going to regroup the terms. I'm going to pull together all the words that occur in the document and all the words that don't occur into two separate products. So that's going to look like that. For the words that do occur in the document, I get PW from the numerator, and I get QW from the denominator, so you have PW over QW. And that's a product of the words that don't occur in the document, and there you get 1 minus PW over 1 minus QW. Now what I'm going to do is I'm going to take this formula. Up until now everything is exact, everything's kosher. And I'm going to divide that by this strange-looking quantity. And I'm going to claim that dividing by that quantity does not affect anything. Okay? So now take a look at that quantity and think about what this actually means. I have a product going over all the words in the vocabulary. Let's just look at the numerator. Product over all the words in the vocabulary, 1 minus PW. Right. So together, that defines the probability of an empty document occurring in the relevant class. It's 1 minus PW. This means that any given word is empty, and it's true for all words. So all words are not present in that document. Similarly, the denominator is the probability of an empty document under the non-relevant class. So this product is really just the ratio of the probability of an empty document under the relevant class to the probability of the empty document under the non-relevant class. And we know that those probabilities are equal. Why do we know that? Well, because we assumed that. Right? And if we assumed that, this means that the ratio must be 1. And I can divide by 1 all I want. Right? So I take my ranking formula, divided by 1, and what it allows me to do is it allows me to further regroup the terms. Because, so think about it. We have some words, very few words, which actually occur in the document, and then probably a million words that don't occur in the document, and for them we have a ratio of 1 minus PW over 1 minus QW. Right? And then we're dividing that all by that product, which is all the words in the vocabulary, 1 minus PW, 1 minus QW. So this 1 minus PWs are going to cancel out all of those guys, and these are going to cancel out all of those guys. But some of them are going to be left over. Right? So all the words that are not in the document will be cancelled out, But for words that were in the document, we're going to have 1 minus PW and 1 minus QW left over. And we're going to take them and move them into that product over there. So after you do that, you're going to get that product. So product over all the words in the document, PW over QW, 1 minus QW over 1 minus PW. So it's getting to be a mouthful to even pronounce, but it should be clear how that guy, how that formula came around. Now, that's a lot of algebraic manipulation. It's based on the fact that dividing by 1 has no effect. You could come up with some nice interpretation of why it makes sense, but what is the real reason we did this? The real reason we did this is we went from a product over the entire vocabulary to a product over just the words in the document. So that was 1,000,000 scalar multiplications, and this is going to be 1,000. Or in a big collection, that would be 1 billion. Right? So what you've done is you have just dramatically reduced the cost of computing this operation.